it's allowed inside the planetarium just because we want to make sure that everybody wears their mask at all times while we're in the planetarium dome. But otherwise, we'll be getting started with our planetarium show in about 3 more minutes. And just another reminder, folks, please wear your mask at all times while we're in the planetarium dome. Make sure to check your neighbor right next to you. Make sure everybody is wearing their mask. Alrighty, everybody. I just got the okay to start our planetarium show, so I'm going to put away our space trivia questions and this important message because now we're going to be heading into the unknown. Ooh. And once again, everybody, welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself real quick. My name is Christian. I'm going to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Hee hee hee. Don't hurt your necks. Look forward into the dome before you. That's where the whole show's going to be. I just want to let you know that I'm here. I'm going to be your space pilot of a sort for this afternoon. And before we get started, kind of curious, how many of y'all have been to a planetarium before? Raise your hand if you've been to one. Ooh, that's a lot of folks in the audience. Welcome back, everybody. How many people have never been to a planetarium? It's your first time. Raise your hand if it's your first time in a planetarium. What's this weird spacecraft? Ooh, welcome, newcomers. Hopefully, by the end of this planetarium show, you'll love planetariums just as much as I do. I love being in here. Everything that you see in purple is going to be one enormous screen, thanks to the help of 6 different projectors hiding throughout the planetarium. That's going to give us that very immersive image. Now, just to let you know, the show that we're going to be watching right now is one of my favorites to do. This is different from all the other shows that we've done here in the planetarium today. It's something that we call Tour of the Universe. Essentially, with Tour of the Universe, what we're going to be doing is that we're going to be starting off close to Earth, and we're going to be zooming all the way out to the very edge of the known universe. Hopefully, by the end of the show, you won't have an existential crisis of where we are, because we are very tiny in the grand scheme of things. Hee hee. And this show is completely live, so you're going to hear my voice, and I want to be actively flying around through the universe. So just a heads up, y'all. But before we get started with our show, I got to go over some quick house rules just so that we're all on the same page. You're going to have a great experience inside the planetarium. There's quite a few of us here this afternoon. First off, there's no food or drinks allowed inside. So if you manage to bring any snacks or beverages, make sure those are put away till the end of the show. We want to keep the theater nice and clean for all the guests coming in today and in the future. And also, remember to keep the feet on the floor and not on the seats, because again, we want to make sure the seats stay nice and clean for all the guests coming in. So please no feetsies on the seatsies. And folks, if you happen to have any 21st century gadgets like cell phones, smartwatches, tablets, anything that produces bright white light or loud sound, now is the perfect time to turn them off, deactivate them, put them away for the next 30 minutes. These are quite distracting in a very dark environment like our planetarium. And also, the most important of them all, folks, please remember to wear your mask at all times while we're in the planetarium. We're going to be in here for about 30 minutes. There looks like there's about 50, 60 of us here in the planetarium dome. So again, please wear your mask. Can't stress that enough. Thank you so much, y'all. And also, folks, if you need to exit the planetarium for any reason, you're more than welcome to do so. The exits are going to be at the very top of the planetarium, so always make your way up the stairs, not down them. The exits are at the top of the planetarium before, during, and after the show. And last but not least, folks, this show is quite immersive thanks to our 70-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy way to ground yourself. All you got to do is close your eyes, take a few big deep breaths, and then your brain will remember that you're sitting in a planetarium and not actually flying through space, at least not more than the usual. Hee hee hee. But with that being said, looks like we're ready for our planetarium show. Are y'all ready? Yeah, all right, cool. Let's get started, everybody. Sit back, relax, and let's begin our tour of the universe. All righty, folks. As I mentioned, we're going to be starting pretty close to Earth, not exactly at Earth, but we can see the Earth just below us right there, that big blue sphere. But we're going to be starting off at this really large contraption. What we're looking at, folks, is something called the International Space Station, or what we like to call it as the ISS, because that's a very long name. But pretty much the International Space Station is the largest thing we humans have put into orbit around our planet Earth. And pretty much it's a research facility that's orbiting around our planet. A lot of countries around planet Earth want to figure out what happens to things in space. So this is one of the places where they can conduct those experiments that they can't conduct on Earth. For example, people around the world want to know what happens when you try to grow plants in space. Do the plants grow the same? Do the roots normally roots grow towards the gravity, but if there's less gravity, where do the roots go? What happens when you try to spark a match in space? Does the flame act the same with less gravity? Does it act differently? So these are some of the different questions that scientists will perform or conduct here on the International Space Station. And just to let you know, folks, the International Space Station looks incredibly large here on our planetarium dome, but it's not that big, so to say. It's only as big as the American football field. So if you've ever been to an American football field, this is how big the International Space Station is. And if you've never been to an American football game, don't worry. You can use the whole California Academy of Sciences as a reference. This is how big the International Space Station is. And also, folks, one of my favorite things is that the International Space Station is going incredibly fast. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And not only that, it also looks pretty far away from the Earth, but it's the International Space Station isn't too far away. It's only about 225 miles above the surface of our planet. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip with the family to get away for the weekend. But folks, just to let you know, this is as far as we put humans into space nowadays because traveling out into space gets quite costly quite rapidly. First, you got to get your hand on a rocket ship or build yourself a rocket ship, and then you got to get your hands on a whole lot of rocket fuel, and I mean a whole lot of rocket fuel. And then you also have to account for all the food, water, all the air you're going to be breathing in space, so the bill starts to get quite costly quite rapidly. And just to let you know, the International Space Station only fits about 6 to 8 astronauts at a given time. Not a whole lot of leg room. They mostly hang out in those middle modules that we saw earlier. But it looks like we've had a nice little tour of the International Space Station. So let's leave it behind. So now we're going to start to see the International Space Station slowly leave or disappear compared to our planet Earth. And as we start to zoom away, we're going to have a nice orbital path so we can keep track of where the International Space Station is compared to our planet. There's that nice orange line. And as we're zooming out, folks, I do want to let you know that the space program that I'm using right here in the planetarium right now is something that you can technically go home and download if you like. The space program that I'm using here is called OpenSpace Project. So if you go to your favorite search engine, type in OpenSpace Project, you can go and download it on your computer. But just a heads up, folks, OpenSpace is not completely finished. It's in its beta phase, so it's not completely finished. So we might experience a few bugs or glitches here and there. If we do, I will point them out for you. And also, just another warning, if you want to download this program at home, make sure you have a relatively new computer or a computer that can process a lot of information and has a lot of space for storage because this is a very large program and it uses satellites around our Earth to constantly update the surface of the planet. So it uses a lot of processing power. But if you don't want to download anything at home and you want to also fly through space like how I am right now, you can also type in NASA's eyes into your favorite search engine, just like the human eyeball, so NASA's eyes. And then from there, you don't have to download anything. You can also still fly through our solar system, which is a whole lot of fun. Highly recommend it. But uh, let's continue with our tour of the universe because now we're going to be making our way over to our nearest natural neighbor in space, the moon. Now, just to let you know, folks, we humans have been to the moon before, but that was quite a while ago, and it looks like we are in new moon right now. Luckily, we are in a planetarium, so I'm going to turn off the nighttime on the moon. Hey, that looks familiar. But again, we humans have been to the moon, but that was quite a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they got to play golf as well. But again, the last time was 1972. That was a little more than 50 years ago or so. But don't worry, NASA has a new space mission in the works that's going to be sending humans to the moon once again in the next few years or so. This new space mission is called Artemis. And pretty much Artemis is going to be sending the first woman to the moon, but not only that, the first person of color to the moon, but not only that, they're also going to be setting up lunar bases around the moon. Pretty much the whole goal for Artemis is to send humans to Mars. But before we send humans deep into our solar system, we got to figure out how exactly we're going to be able to survive out here in space. So again, instead of sending them to Mars, we can use the moon as a great stepping stone to figure out all those logistics, how exactly we're going to be doing that. And as I mentioned, they're going to have to set up different lunar bases across the moon. So you can imagine a lunar base right over here, maybe but closer to the mountains, maybe a lunar base over here by this large crater. Maybe you want to go check out the plains over here. So maybe they'll set up a lunar base. So they're just going to be scattered all around. But what's also really neat is that they're also going to have a lunar, something called the Lunar Gateway, kind of just like the space station that we just saw, the International Space Station, that's going to be constantly orbiting around the moon. So if anything was to go wrong, these astronauts can get in their spaceship, blast off the lunar surface, and then head back to that space station that's orbiting around where they could be safe. So pretty cool. Look out for any news about Artemis in the coming years. Should be happening in the next few years or so. And folks, here on Earth, when we look up at the moon, it looks incredibly close to us. Sometimes you can feel like When you're looking at the moon, you can reach out and touch it, but the moon is incredibly far from us. It's roughly about 240,000 miles away from the Earth. Now, some of the adults in this room may have a car with that many miles on it, and if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop, going about 80 miles per hour. But I wouldn't recommend it. The roads out here are poorly maintained. Hee hee hee. And from here on now, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities. So astronomers use a more convenient measurement known as light speed. Now, light travels at a mind boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, we must leave our moon. So everybody say bye bye, moon. We'll see you later. And on our journey, folks, we're going to be taking a leap into a much greater realm of our solar system because now we're going to watch the moon and the Earth in its orbits as they slowly recede. And let me bring up all those planet trails so we can see where everything is in space. So we can see the lunar orbit right in front of us. And there goes our Earth's orbit as well. Now, on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace, showing us the most accurate images and information available to us. And now, the nearest star to us, the sun, comes into view. Here comes the sun. Do, 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 do. And the sun is incredibly far from us, folks. The sun's about 93 million miles away from the Earth. Whew, 93 million miles away. That's incredibly far away. But again, not too far away in terms of speed of light. So again, Earth is the third rock from the sun. So we're right over here, third rock from the sun. And the sun's over here. So it takes about 93 million miles for sunlight to travel that distance and to reach us here in space. Now, that's a really cool concept to keep in mind because let's say if the sun was to turn off all of a sudden, we wouldn't know about it here on Earth for about 8.5 minutes because that last bit of sunlight would travel that distance and reach us. So you can imagine the sun turning off all of a sudden. That last bit of sunlight travels at 93 million miles away, and then all of a sudden the daytime here on Earth would turn into nighttime. Now, this is also a really cool concept to grasp because this also works for really far away objects as well. For example, let's say we're looking at a star that's 70 light years away from us here in our solar system. Well, we're looking at that star as it looked like 70 years ago because that light that's reaching us now traveled 70 years through space to reach us. So when we look at really far away objects in space, it's kind of like looking back in time in a sense. Pretty cool. But right now, folks, it looks like we have a nice bird's eye perspective of our solar system. So really quickly, I'm going to name all the stuff in our solar system just to get a sense of what we've got going on in here. And right in the middle, we have our star, the sun, the biggest thing. The closest planet to the sun is going to be Mercury. Then we have Venus, Earth, that's us. And then we have Mars. These are the rocky terrestrial planets in the inner solar system. And then beyond these rocky planets, we have something called the main asteroid belts. And this is what it would look like to highlight all those asteroids in our asteroid belts. There we go. It always gives our computer program a second or two to load them up. There's a lot of asteroids there. And then beyond the asteroid belt, we have the really big planets. We have our gas giants. We've got our Jovians. Whoop, there's a little bit of glitchiness. Sorry about that, folks. But beyond the orbit of our main asteroid belt, we have the really big planets, the Jovians. We've got Jupiter, and then we also have Saturn. And then beyond them, we have our icy gas giants. We've got Uranus, the funny one, and Neptune. And of course, I can always add everyone's favorite and lovable dwarf planet, Pluto. And here is the orbit of Pluto, different from the other objects that we just looked at. And just to let you know, folks, Pluto is part of this thing in the outer part of our solar system called the Kuiper Belt, which is something that resides past the orbit of Neptune. And you're probably wondering to yourself, what's the Kuiper Belt? I've never heard of that before. Well, the Kuiper Belt's going to be all this stuff past the orbit of Neptune. So you can think of the Kuiper Belt as a second asteroid belt in the outer part of our solar system. Mostly what you're going to find out here are icy asteroids and short period comets, comets that don't travel too far away from the sun, so they have very short trajectories. But this is the Kuiper Belts. I'm going to put that away for now because that's just a whole lot to look at. But right now, I'm also going to be adding on screen some of the different spacecrafts that we sent out in the 1970s to explore our solar system so we know more about it. And just give it a second. There's quite a few of those spacecrafts that we sent out. There we go. So on screen right now, we have Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons. So all these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures, Voyager 1, has not yet traveled as far as light travels in a single day. Now, in order for light to travel all the way to the orbit of Pluto, it's about 5 light hours. So nowhere near close to a day. So 8 minutes to get to Earth, and then 5 hours to get to the orbit of Pluto. But let's leave our planetary system behind because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us over 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. All right, so our solar system is going to be right over here in the middle that we're centered on. And the closest star system to us is Alpha Centauri, which is going to be directly above us. So again, 4 years at the speed of light to cross this distance. Now, 4 years at the speed of light doesn't sound too bad, but if we were to get in a rocket ship of today's capabilities and left Earth right now and travel to the next star system, it's going to take us about 8,500 years to get to the next star system. So a very, very long road trip. But let's stop and consider whether humanity has made its presence known beyond our solar system, because now, folks, we're going to be stepping inside something called the radiosphere. Whoa. So we are now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out for the Earth. Now, this first began in the early 1930s with strong radio waves and early television and radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. Now, humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they travel at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody out there listening? And also right now, folks, I'm going to be adding some markers onto the screen. These markers represent some of the many thousands of stars astronomers have discovered over the last 22 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found about 5,000 exoplanets, approaching 5,000. And you can see that we're constantly scanning the night sky. We can see a nice chunk of exoplanets right down here on the bottom left of our screen. So we just pointed our space telescopes in that direction. We're able to find a whole heap of exoplanets. And we have space telescopes where their whole purpose is to find as many exoplanets as possible. But are any of these exoplanets suitable for life as we know it? Well, our technology is not yet able to answer that question, but new generations of new astronomical instruments, space telescopes, are devoted for that search. So in the next coming years, we'll be able to answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there that's able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system inside of our radiosphere. Let's say this one right over here, and we want to we find an alien civilization, let's say 60 light years away from us right over here. We shoot them a text message. We say hi. Takes 60 years to get to them. They listen in, reply, another 60 years for that message to get back to us. That is a 120-year conversation in the making. Whew, I could barely wait for a text message from my friend. But of course, folks, planetary systems beyond our radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, I'm going to be putting away our exoplanet markers, because that's just also a whole lot to look at. But I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. So keep your eyes on that radiosphere. Let's see if you can still see it as we zoom out and see our galaxy. All right. Can anybody see their house from here? Just kidding. You would have a really big house. But, anyways, folks, we are now looking down at our Milky Way galaxy, and our Milky Way galaxy is incredibly large. If you wanted to cross our galaxy from one side to the other, it's going to take you about 130,000 years at the speed of light. Whew, that is a very long time. But not only that, our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within this small neighborhood, within this vast star city, is any indication, there could be billions of planets and potentially millions of Earth like planets throughout our single Milky Way galaxy. And before we leave our Milky Way galaxy, I do want to stress the shape of it. When we look at our Milky Way galaxy from a sideways perspective, you're going to notice that we live in a flat spiral disk. So keep this in mind. This is going to come important later on in the show. When astronomers and scientists want to learn about our universe, it's so much more easier for them to point their telescopes galactically north and galactically south instead of looking through the plane of our Milky Way galaxy, which has planets, stars, gas, debris, black holes, things that obscure their view of the universe. So, again, keep that in mind. We look galactically north and galactically south instead of looking through the plane of the Milky Way. But, folks, our Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So, in this giant leap, we're now going to see a view where each point of light no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, just to let you know, we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest spiral galaxy to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as our picture starts to expand even more so, we discover that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, and they also like to avoid each other where they tend to leave large voids or gaps. So we can see a nice galaxy cluster right over here in the middle of our screen. We can also see some voids where there's very few galaxies towards the top and the left side of our screen. So keep that in mind. Galaxies like to stay together in groups or they like to avoid each other, kind of like people. But folks, we've zoomed so far back now that this picture represents the closest 30,000 galaxies to us in space over 300 million light years. We got to give props to an amazing astronomer by the name of Dr. Brent Tolley, who worked at the University of Hawaii, who compiled this amazing galactic map thanks to the work of dozens of other astronomers working over decades of time. So big shout out to Dr. Brent Tolley. I love flying through this galactic map. But folks, we now have automated systems that are mapping even the most distant galaxies. So now we're going to start to see the large scale structure of the universe. And remember, every single point of light that you see is an individual galaxy, not a star. So again, folks, we are now looking at the large-scale structure of the universe. And just to let you know, the universe is not shaped like a bow tie or a butterfly. Remember when I just mentioned that we live in our flat spiral disk of our Milky Way galaxy? Well, if we were to line up our Milky Way plane, it would line up directly like so, where there you see very few galaxies. So again, astronomers like to point their equipment galactically north or galactically south. But we still want to make sure that there was galaxies through the plane of our Milky Way. So we have this nice purple survey of galaxies right over here. You'll notice that we couldn't find as many galaxies compared to looking north or south, and it doesn't go as far out. Pretty much we have to wait for our technology to improve in order for us to look out past the plane of our Milky Way galaxy. Once we are able to do that, then we'll be able to map out all those galaxies that we haven't filled in yet. It's just a matter of time. But we still need to continue moving further out because it looks like we're running close out of time, folks. 30 minutes is not enough time to tour the universe. But now we're going to be looking at really distant objects, these orange dots at the very edge of the large scale structure. What we're looking at here are the quasars. Now, quasars are short for quasi-stellar radio sources, and these blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So now we're going to be looking much further back before a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the known universe. And here we are. So, what we're looking at now, folks, is something called the cosmic microwave background image, or what we also like to refer to as the CMB image. Now, all evidence indicates that the universe that we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And it's not a typical photo, what we're looking at either, but a temperature density image where the light echoes of the Big Bang are color coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000. But eventually, they gave rise to that large scale structure of the universe, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us, so we only have one direction left to go, and that's going to be back home. Now, before we make our return trip back to planet Earth, I've got to ask y'all to prepare yourself because this could possibly be the worst free falling dream ever. Hee hee hee. But let's return back to planet Earth through all these quasars and galaxies. So, folks, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons, observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our Milky Way Galaxy. We're going to run right through that radiosphere, and we're making our way back to our planetary disk. And of course, we are making our way downtown, walking fast faces past our homebound. And we are now passing those spacecrafts we sent out in the 1970s, passing the Kuiper Belt and our Jovian giants. And we're making our way to the third rock from the sun, the only place humans have ever lived, and all the humans we know. And we're about to pass the orbit of the moon, the furthest point we've ever sent humans out into space. And folks, as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with me this afternoon. I hope you did enjoy it. But otherwise, that's all for today. And thank you for joining me, folks. Have a good day.